Ashley Applegate here with Kentucky Welding Institute. We're going to spend a few moments talking about the tools that you would use on a CWI Part B exam, or the tools that you may see for Skills USA National Weld Inspection during your national welding competition. So let's talk about the tools for visual identification purposes so you'll know what they are when we start using these tools. When we're starting with the kit, obviously the first three tools are self-explanatory. We've got a flashlight, we've got a mirror in case you need to look inside of the pipe. We also have a magnifying glass for those precision measurements. Next up, we have the surface roughness guide for oxy-fuel cutting. We have a high-low gauge. We have an angle finder. We have a dial caliper. We had a 6-inch scale, the V-WAC gauge, and finally a set of fillet weld gauges. The fillet weld gauges include 7 blades that will measure 11 different welds. So we're going to start using some of these tools so you can see practically how you could put this into play for your Part B or your Skills USA visual inspection exam. So the first thing I'm going to grab is this surface roughness guide. The way you may use the surface roughness guide is to determine whether a weldment meets which different criteria on this guide. So in this case, from our molds, we have a torch cut, and then we would simply hold the surface roughness guide near these torch cuts, and then we can decide which one it's going to be, and then we would mark the appropriate answer for the surface roughness guide. A pretty simple tool for you to use. Next up, we have the high-low gauge. The high-low gauge is going to slide out. You've got 2 fingers at the side, and then you can lock it in. Looking at the molds that we have, the pipe would be a great example on how we could use the high-low gauge. The high-low gauge has a red knob on it. So when we insert it into the pipe, then we pull down, and then we can set our gauge, and then we can determine, are there any high-low mismeasurements in this particular pipe. So we look at this, and then we're going to zoom in on the number, and we can see that we are just barely a high-low misalignment. So next up, we're going to talk about the angle finder. We've got a mold sample that has 4 different angles on it. Depending on what you're going to measure, you may measure the obtuse angle, which is bigger or larger than 90 degrees, or you may measure the acute angle, which is smaller. Always think of the acute angle as tiny, it's under 90 degrees. A lot of times when you're going to bevel your plate before you weld, you're going to bevel to a 22.5 degree or a 30 degree or sometimes a 37.5, depending on what your particular weld test calls for. So if we were going to measure the acute angle sample here, then we would put this underneath, and then we would read the smaller number. Notice the angle finder has numbers that are both above 90 and below 90. So as we're reading the smaller number, then this angle is going to be somewhere around that 45 degree mark. However, if we were going to be measuring the obtuse, which is the larger angle, then we would have this above, and then we would read that particular number that it shows us, and in this case it's somewhere around the 135 degree mark. So keep that in mind. Are you reading the obtuse or are you reading the acute side of your angle finder? Next up, we have the dial caliper. The dial caliper is a really awesome tool that can be used for many, many different things. One thing I like to use the dial caliper for is for measuring weld discontinuities, and also the dial caliper is great to measure the thickness of that finished weld test coupon to make sure you're within tolerance before putting it in the bend machine. Using the dial caliper for the first time, I want to make sure it comes to the perfect or absolute 0. So I'm going to slide it in until it closes, and then I'm going to look at the gauge. If the gauge isn't on exactly 0, then all we have to do is turn the adjustment, whichever direction it needs, until we read 0, and we're all the way closed. This dial caliper has a clicker so that it clicks when we know that we are tight enough. The next thing on the dial caliper, I'm going to slide this out a little bit so we can zoom in and we can see a set of numbers here. Those smaller numbers indicate the tenths, so it's going to be the first number after the decimal point. The larger number 1 indicates an inch. So if we come further out, I've got 2-inch and I've got 3-inch mark. So let's set this thing at 1 inch, and when the dial is on exactly 0, that means we are at 1 inch exactly. If we go above the 1 inch mark, now I'm showing and setting exactly on the 1. So this would be 1.1. However, if we are a little bit more, now I'm showing the whole number of 1 inch. I have the next digit showing, which is 1.1. And then over on my dial, I am 40. So this would be 1.140. And that's how you read your dial caliper. If the dial caliper is below 1, so in this case, we're showing the 4, and then we are right about 59. So this would be 0.459. So now let's put the dial caliper in use and show you some things that you can do with it. Maybe you need to check the thickness of a weld sample. So you would run the dial caliper in and check the thickness of that sample. Be really cautious. If you angle the dial caliper, see how it changes? You want to make sure that you're exactly square. One thing I like to do when using the caliper is I will get my measurement and then I will write it down, and then I will check again in a different or similar spot to make sure my measurements are going to match. If I was going to use the dial caliper to look for weld discontinuities, then what I would do would be bring the dial caliper in, I would close up near the edges of that discontinuity, and then I would read the amount we have. So in this case, we're showing the whole number 1, but we're not showing the number 2. So I'm at 0.1, and then over here on my dial, I'm showing about an 87. So this would be 0.187. As most codes would say, 0.125, an eighth of an inch, is going to be a pass, and 0.126 or above is going to be a failure. So read the amount of the discontinuity, and if you're unsure, or if you don't see the correct answer on your particular test question, then maybe you reset your caliper, you come back, make sure it's on absolute 0, and you measure this one more time to make sure that the number you have chosen is exactly the number that you want this to be. So when we come back to this one more time, I'm closing in on the edges of that discontinuity, and once again, I have the 1 showing, so I'm 0.187. So that would be the number or the answer that I would look for on my particular test. So the next tool that we're going to look at is going to be the 6-inch scale. The 6-inch scale is going to be broken down into different increments. Sometimes a 6-inch scale on the back side will have a conversion from decimal to fraction. This particular 6-inch scale is broken down into 1/8 inch, it's broken down into 32nd, it's broken down into 16th, and it's broken down into 64th. A good way to use the 6-inch scale, once again, if you're looking for discontinuities. So I would pick up my completed bend samples, and then I would use that 64th inch scale to measure some discontinuities, and then I can add up those amounts. So whether you use it from the front or the back, so here we start at the discontinuity, the very edge of that, and then we write that number down. We would measure the next discontinuity, write that number down, and determine, are these discontinuities acceptable per the code? Some people like to burn an inch, which means instead of starting at the edge of the 6-inch scale, they would start at the 1, and then it gives them a little bit easier reference. If that's the way you would like to measure, then that is absolutely acceptable as well. The next tool we have is the V-WAC gauge. The V-WAC gauge can do a few different things. So first of all, when we're looking at the V-WAC gauge, we want to make sure that this is absolute 0. So I like to pick up the 6-inch scale and set the V-WAC gauge right on the bottom of it, because I know my 6-inch scale is straight, and when I put this, everything exactly lined up, then that 6-inch scale is pointing to exactly 0. If we go into a discontinuity and the needle dips into it, we can see that it raises above. So that's going to be the depth of undercut. When we move up with the needle, now we can measure the crown height. So the gauge at the end is going to dip and show us which measurement that is. So let's put this thing into some practical use for some examples that you may see on a visual inspection or a Part B exam. One thing you may use the V-WAC gauge for is measuring weld height reinforcement. So I just take a particular sample and I make sure that I'm flat across the weld, and then I push down to what I feel like is the highest point of that particular weld. So now that I'm on that highest point, then I simply want to read the number on the V-WAC gauge, and this particular one is pointing to right at a 1/16 of an inch. So on this particular weld sample, we have a 1/16 of an inch of weld height reinforcement. You would have to look at your code and you would have to determine, is this the amount of reinforcement that is acceptable or is it rejectable? The V-WAC gauge can also be used to check for undercut. So we're going to pick out a particular weld here that has some undercut on it, and we're going to take that needle and we're going to drop in to what we feel like is the deepest point of undercut. Check a couple different areas around that weld on both sides of the weld. We drop into that lowest point of undercut, and then we once again read that gauge. So now we're above the line and we're reading it just barely above. So there's only about a 1/64 of an inch of undercut on that particular weld as we measure that. So those are a couple ways that you can use the V-WAC gauge for weld height reinforcement. You can also use the V-WAC gauge for measuring undercut. And finally, we have the fillet weld gauge set. Fillet weld gauge sets are used to measure concave welds and convex welds. So we would pick up our fillet weld sample and we would check to determine, is the right size weld in the right spot. So I have the 5/16 fillet weld gauge sample in my hand. If you'll notice, we have a line on the fillet weld gauge. That line is going to be from the edge over to the line is going to be 5/16 of an inch. Also, from the very bottom up to this leg is going to be 5/16 of an inch. So you can use the fillet weld gauge standing up. You can use the fillet weld gauge laying down. You want to make sure that you check the full length of the weld that is available for you. So I don't just want to check one spot. So when I check a spot and I see that the fillet weld gauge is right at the top height of that, but then I have another spot where it's a little bit low. So in this case, the weld will be under the 5/16 that would be allowed. I can also come in the opposite direction and look this way. So in this case, this lower leg is hitting the weld. So in that case, this weld would be just over the 5/16. If you're trying to determine the weld size, you may have to use 3 or 4 of these to determine. So if we were touching the weld on the 5/16, I may lay that one down, grab the next size up, and then see if that one fit or not. So that's how you can use your fillet weld gauge to determine weld size. But it's always important to measure the entire length of that particular weld. Fillet welds on a lap joint are a little more difficult to measure because it's hard to come in from the top side. So in that case, you're going to have to use the line that exists on there. So now we're determining by the line, does that weld meet the criteria or is that weld undersized when you're looking at those particular fillet welds from a lap joint standpoint. So these are the tools that you would find on a typical CWI exam in a typical CWI kit, and these are the types of tools and molds that will be representative of when you take your visual inspection test at your National Skills USA welding competition. So we hope this video will be helpful in your needs to attain your CWI or your success in passing your Skills USA visual exam test.